Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0335 pertains to a CKP Sensor No Signal issue specifically for the Honda Civic models produced between 2006 and 2011. This code indicates that the Engine Control Module, ECM, which is responsible for managing various engine components and performance, is not receiving the expected signal from the Crankshaft Position CKP sensor. The CKP sensor plays a crucial role in providing the engine's rotation position to the ECM, thereby influencing ignition timing and fuel injection. If the CKP sensor fails, it can lead to poor engine performance, stalling, or an inability to start. Its location is usually near the crankshaft, where it can measure the crankshaft's position accurately. Understanding this code is essential for diagnosing and rectifying issues with engine performance. The Crankshaft Position CKP sensor is a pivotal component for engine management, specifically found near the crankshaft in the Honda Civic. Its primary function is to monitor the position and rotational speed of the crankshaft. This data is critical as it directly affects the timing of fuel injection and ignition, enabling smooth engine operation. When a CKP sensor fails or malfunctions, it sends no signal to the ECM, triggering the P0335 DTC and potentially causing serious performance issues. Therefore, it's essential to understand both the role of the CKP sensor and its exact location when troubleshooting this issue. Without it, the engine may exhibit erratic behavior or fail to operate. Understanding the possible causes of the P0335 DTC is crucial for effective troubleshooting. One common reason is a faulty CKP sensor, which may be damaged or simply wearing out over time. Additionally, wiring issues can occur, where the electrical connection between the CKP sensor and the ECM is disrupted or frayed. This might even include breaks in the wire harness that may not be immediately visible. Moreover, loose or corroded connections at either the CKP sensor or the engine control module can prevent accurate signal transmission, leading to the DTC being triggered. Identifying these potential causes is a vital first step in resolving the problem efficiently. Several symptoms may arise when the P0335 code is triggered, notably impacting vehicle operation. The most immediate symptom is that the engine may not start at all, as the ECM cannot determine the crankshaft position. Additionally, if the engine does start, it may stall unexpectedly during operation, causing severe safety risks. Drivers might also experience notable drops in engine performance, including misfiring or difficulty accelerating. Understanding these symptoms can not only help in the initial diagnosis, but can also service technicians recognize how critical it is to address this DTC promptly. Addressing these issues early on could help prevent further complications and ensure optimal vehicle performance. The first troubleshooting step in addressing DTC P0335 starts by turning the ignition switch to the on position, known as the I position. This action powers up the vehicle's electrical systems and is crucial for diagnostic assessment. Before proceeding further, it is imperative to record all freeze data available. This includes valuable information about the vehicle's operation right before the fault occurred. Additionally, reviewing general troubleshooting information aids in understanding the context of the reported code and can provide vital clues for further diagnosis. These preliminary steps lay an important foundation for more in-depth investigation and ensure that any existing data is captured that can assist in the repair process. In the second step of troubleshooting the P0335 code, it's essential to clear the DTC using the Honda Diagnostic System, or HDS. The HDS is the specialized tool used for diagnosing and clearing trouble codes in Honda vehicles. By resetting the DTC, you will prepare the system for any further readings, which may reveal if the issue persists. After clearing the DTC, it's critical to conduct a general check to ensure that there are no stored codes before proceeding further. This step is crucial in distinguishing between intermittent faults and persistent issues that may require more detailed investigation. Properly executing this step can streamline the troubleshooting process and set the stage for identifying the root cause of the problem. The third step involves starting the engine after clearing the DTC to see if the problem resurfaces. It is essential to observe indicators on the dashboard during this phase. Using the Honda Diagnostic system, check for pending or confirmed DTCs again. If DTC P0335 reappears, this indicates that the CKP signal issue still exists, requiring further inspection. If the DTC does not reappear, you may be dealing with an intermittent problem, ensuring the system seems operational at this time. It is critical in this phase to remain vigilant for any unusual noises or behaviors from the engine that might indicate an underlying issue. Understanding the results of this step is vital for advancing to more targeted inspections. At this stage, confirming whether the DTC P0335 is indeed present allows you to proceed with more specific troubleshooting steps. If the code has reappeared, indicating a stable issue, you should take it as a priority to investigate deeper into potential causes. It's essential to understand that a confirmed DTC means the system is acknowledging a fault that needs resolution. By confirming its presence, you affirm the initial signs of failure in either the CKP sensor or its associated wiring. This confirmation also guides you in determining whether more complex diagnostic measures are needed, or if there might be an intermittent fault, in which case, further inspection of the wiring or connections is warranted. Knowing this allows you to methodically work through the problem until a resolution is found. In this fifth step, start by turning the ignition switch to the lock position, known as 0, which ensures that all electrical systems are powered down safely. After turning off the ignition, the next action is to disconnect the CKP sensor's 3P connector. This is an important step, as it isolates the sensor for further testing and allows you to examine if the problem lies within the sensor itself or in the wiring leading to it. Properly performing this step is crucial, as it lays the groundwork for voltage measurement procedures that will follow. Ensure to handle the connector carefully to avoid any potential damage. This action is critical for ensuring accurate diagnostic readings in subsequent steps. With the CKP sensor disconnected, the next step entails turning the ignition switch back to the on position I. This action powers the system again to allow for voltage measurements. Utilizing a multimeter, the next task is to measure the voltage between the CKP sensor's terminal number 3 and body ground. This measurement checks if the circuit is providing the necessary voltage. If battery voltage is detected at this point, it indicates that the circuit leading to the CKP sensor is functioning properly. Nonetheless, if there is no battery voltage, this highlights a potential open circuit issue in the wiring. It's critical to document any findings at this stage, as they inform your next steps in diagnosing the fault. In this step, confirming whether you detect battery voltage is essential. If voltage readings appear normal, it suggests that the wiring leading to the CKP sensor is intact and functioning as expected. However, if the voltage is absent, it points to a likely open circuit that needs rectification. In such cases, your next action should be to repair any breaks or faults in the wiring between the CKP sensor and the PGM-FI main relay 1. Ensuring that voltage is restored to the CKP sensor circuit is crucial for proper sensor operation and engine performance. Repairing this issue might involve replacing damaged wiring or securing loose connections. Always make sure to examine the wire harness carefully for visible damage or corrosion throughout this process. The 8th step requires measuring the voltage at CKP sensor 3P connector terminal number 1 and body ground. This reading is crucial as it determines whether the CKP sensor is receiving the proper voltage required for operation. You are looking for about 5 volts, which confirms that the sensor is receiving adequate power. If this voltage level is present, it indicates that the CKP sensor could potentially be functional, and you can proceed to further diagnose any other issues. Conversely, if the voltage is incorrect or absent, there may be additional problems, such as faulty wiring or a damaged sensor. Documenting the findings at this stage is essential, as it shapes the next troubleshooting steps based on voltage readings. Always ensure the connection is secure during these measurements for accurate readings. Upon completing the necessary repairs for DTC P0335, the final repair verification process becomes essential to ensure everything is functioning correctly. Start by reassembling all components, including reconnecting the CKP sensor and securing all connectors that were previously disconnected. After everything is put back in place, it's vital to conduct a test drive of the vehicle under various conditions to monitor whether the engine is performing optimally. Following the test drive, use the Honda Diagnostic system to verify that the DTC is no longer present. This step acts as a final confirmation that the fault has been successfully addressed. If the DTC remains, you may need to revisit the previous troubleshooting steps to ensure no underlying issues persist. This thorough verification process assures that the vehicle is safe and fully operational. While addressing DTC P0335, preventive maintenance plays a vital role in avoiding future issues. Regularly inspecting electrical connectors associated with the CKP sensor can often prevent unexpected problems. Loose or corroded connections are common culprits in sensor malfunction. Furthermore, routinely checking the wiring for any signs of fraying, breaks, or corrosion is essential for maintaining solid electrical pathways to the sensor. Keeping the CKP sensor clean and free from debris will also help in ensuring accurate performance. By conducting these preventive maintenance practices, you can increase the longevity of your vehicle's components and prevent the recurrence of DTCs related to CKP sensor issues. Prioritizing this aspect ensures your Honda Civic not only performs well, but also stays reliable in the long run. In conclusion, understanding DTC P0335, which signifies a CKP Sensor No Signal, is vital for diagnosing engine performance issues in the 2006 to 2011 Honda Civic. The Crankshaft Position sensor plays a crucial role in delivering necessary data to the ECM for optimal engine function. By following the outlined troubleshooting steps rigorously, you can effectively diagnose and rectify this issue. Recognizing the possible causes and symptoms is equally important, as these factors guide technicians in pinpointing the fault accurately. Moreover, implementing preventive maintenance can significantly reduce the chances of recurrence. Engaging in a thorough review and applying best practices will ensure a stable and efficient engine operation, enhancing both performance and reliability in the long term. Please like and subscribe to the channel. See you next time.